In this video, we'll take things a more realistic step forward and we'll solve equations involving multiple operations. When this is the case, you have to remember when you're evaluating, you use the order of operations, BEDMAS. So B for brackets, E for exponents, D and M for division and multiplication, left to right as they occur, and A and S addition and subtraction left to right as they occur. However, when we're solving for an unknown, we essentially are moving in a backward sense. So we don't do BEDMAS, we reverse the order. And you can call it something like SameDeb, although that doesn't make much sense. So when it comes to rearranging, what we want to move to the other side of the equation first is SA, the addition and subtraction. Then the next thing you're going to get rid of is M and D, multiplication and division. Finally, you're going to get rid of exponents and then brackets afterwards. So we always have to keep that in mind that we're going in the opposite direction. Now let's take a look at some examples done by hand. Let's look at our first example here where we have 2x plus 2 is equal to 8. So remember, to isolate for the x here, we're going to isolate for the x here, we're going to go in the opposite order of the regular operations. So that means we'll move this plus 2 over to the other side first. So at this point we're going to say 2x plus 2 minus 2 is equal to 8 minus 2. So this part here will cancel out, and you'll end up with 2x is equal to 6. So now that we've gotten rid of the addition and subtraction, and there's no more of that, now we move on to the D and M, the division and multiplication. So we have a multiplication by 2, and we need to get rid of that with a division, and whatever we do to the left, we do to the right. So that would cancel out to give 1. So it's just x on the left, and 6 divided by 2 is equal to 3. In this situation here, we have two copies of x. We've got x over here and x is over here. But building on our ideas of basic algebra, 3x and 5x are actually like terms. So we can collapse these two x's to a single x by adding or subtracting like terms. So let's move them over to one side of the equation, and we'll try and push everything else to the other side. So I'm going to try and get this 3x over here first. And we'll do that by taking a minus 3x on both sides. So 5x minus 3x minus 2 is equal to 8 plus 3x minus 3x. So again, I've put the 3x in the middle here because that's what's most convenient for me, because I want to rearrange so that the like terms are next to each other. So on the right hand side we get cancellation, and 5x minus 3x leaves us with 2x minus 2 is equal to 8. And now, very similarly to the last one, we're going to get rid of the minus 2 first. So we're going to add 2 to both sides. And you can see on the left that both cancel there. And so we're left with 2x on the left, and on the right hand side, 8 plus 2 is 10. Finally, we have a multiplication by 2. So we want to get rid of that by dividing by 2. So we do that on both sides. 2 divided by 2 is 1, so x is equal to 10 over 2, which is 5. I'll just do this one more time, skipping a bit of these steps where we're adding the same thing to both sides, just so you can see what that looks like. So in the first step, I moved the 3x over to the other side. So its opposite operation was a minus. So then you might see someone just write it as 5x minus 3x minus 2 is equal to 8. So they'll just skip the whole canceling on the right-hand side and just write what the left-hand side would be equal to. So now we'd simplify, we get 2x minus 2 is equal to 8. And then you might see a step that just says 2x is equal to 8 plus 2. The opposite operation for the subtraction here on the left becomes an addition on the right. And then you'd get 2x is equal to 10. And then you'd probably see the division by 2 happen the same way here. X is equal to 5. So this is a more realistic version of what you might see someone do on a whiteboard or in front of the class. Next we have x plus 2 in brackets divided by 2 is equal to 8. So remember, brackets will be what comes last because under normal order of operations, they happen first. So that means we'll do them last. So we'll get rid of the division by 2 first, and we're going to do that by multiplying by 2. So over 2, but then we're going to multiply by 2 is equal to 8 times 2. So remember, this is really a 2 over 1 on the left-hand side and on the right-hand side. But because the left-hand side is a fraction, you might want to remember that's how that works, because now we're going to multiply our fractions, top times top, bottom times bottom. So if I want to write out that step just to be similar with what we were doing before, it would look like x plus 2 over 2, like this, and then you would cancel out the 2. And 8 times 2 is 16. So now x plus 2 is by itself. Those brackets aren't really sheltering it from anything or grouping it together from anything else. So the brackets actually just go away. X plus 2 is equal to 16. Then we're going to subtract 2 to get rid of the positive 2. But then we do that on both sides. So then finally, x is equal to 14 because this canceled out. Question 4, all of our x's here are in the denominator. So when we saw an example like that in the slideshow last time, we tried to multiply by something with an x in order to get it into the numerator. So we're going to do a similar thing here. However, what we're going to do is multiply by more than just x, because if we multiply by 3x, which would actually be the LCD here between these fractions, if we multiply any equation with fractions by the LCD, we'll end up clearing out all of the fractions in the whole equation. So I'll just write out that the LCD here is equal to 3 times x. If you're not sure why that is, just remember that the LCD, or any common denominator, is one that every denominator can divide into the LCD. So even if you're not sure why it's 3x, just ask the question, can 3x divide 3x? Can 3 divide 3x? Can 3x divide 3x? We answered yes in all 3 of those cases, so this would work. So let's multiply both sides in total. So we're going to introduce brackets here, because when you multiply the left-hand side by 3x, we are multiplying the whole left-hand side, so we have to group it together. It's a little bit easier to do the right-hand side. You can still write brackets, but there's less chance of you making a mistake because there's only one term on the right-hand side. So working with the right-hand side here, we can see that this cancels out and we just get 10. And now 3x, let's distribute in. Remember, you always have to distribute, and that was really the point of writing those brackets, as a big reminder to distribute. So we'll have 3x times 25 over 3x plus 3x times 1 over 3. So the 3x will cancel out in the first term, and then the 3 can cancel out in the second term. So simplifying here, we just have that 25 plus just the x is what's left over, because it's x times 1 is equal to 10. So now to get rid of the plus 25, we're going to say 25 minus 25 plus x is equal to 10 minus 25. So they cancel out on the left, and you get x is equal to 10 minus 25, which is minus 15. In question 5 here, again, we have x's in the denominators, which are the trickiest places to start, and we want to get these things into the top. So this is the only appropriate situation where you're going to do something called cross-multiplying. Cross-multiplying works when you have a monomial on the left and a monomial on the right. They're both fractions, and the variable you want are in the bottom. What people usually do is they write an x like this to denote the cross-multiplication. And really what's happening is we're multiplying by both denominators at the same time. So that looks like an x times x minus 1 times the left-hand side of 3 over x minus 1 is equal to 6 x minus 1. Oh, and this was over x as well. I'll also mention, just for your benefit, that x times x minus 1 here is also the LCD. So it follows the same strategy up above, just coming up with the LCD when you're dealing with algebraic expressions is a little bit more beyond the scope of what we're doing in this section here. But the cancellation that we can see that happens is x minus 1 would cancel on the left-hand side, and x would cancel on the right. So the effect is that we have 3x on the left and 6 times x minus 1 on the right. And that's why it's called cross multiplication, because it looks like the x minus 1 goes to the right and the x from the right goes to the left. So now simplifying out, we have 3x equals, and we're going to distribute 6x minus 6. It's always important to distribute. And now we have another similar situation where we have 2 copies of our x, but they are like terms. So if we move one to the other side, then we should be able to condense them into a single copy. So let's move this 3x over to the right side so that when it becomes a subtraction, we still end up with an overall positive x quantity. So we'll say 3x minus 3x is equal to 6x minus 3x minus 6. That will be 0 temporarily. And then we'll have 3x minus 6. And let's just continue this over just right here. Then we'll move the minus 6 over to the other side. So we'll end up with plus 6 on the left is equal to 3x minus 6 plus 6. That cancels out to be 0. So 6 is equal to 3x. And now finally we get to divide by the 3. That would cancel out to give 1. So x is equal to 2. At any time you can always switch to the left-hand side and right-hand side, because a lot of the time it looks better to say x is equal to 2. They say the exact same thing, but that's just kind of a preference.